Hi, let's have a look at how to work the pipe network program. It looks like this. We've got a bigger and better legend, a lot of detail, a lot of pretty colours. Enter our catchment areas, enter our pipelines. There's so much information now I've had to resort to scrolling backwards and forwards to read this. Just put your cursor outside that little box and you'll scroll everything else. A lot of information, a lot of details further down below. Now the major thing on entering anything in this is the data. How do we enter the data in the correct manner? So the naming convention is very important. So let's have a look at how the naming convention is derived. We start with the roof. Enter your downpipes wherever you see fit. Now calculate your catchment areas for each downpipe. You'll note that the downpipe pipes are given the same number as the catchment area. It's important. Catchment 5 to downpipe 5, etc. Draw in your pipelines. Now we must number all the junctions, or shall we say, put a letter on all the junctions. A, B, C, D, etc., etc. The junctions are also called nodes. We can put extra nodes anywhere we like, and we do that if there's a serious change of grade going to occur. We might have some other entry points around the site, and they're given a catchment area too. Only one catchment area is allowed per inlet structure, so whatever's going into there combined all in one big catchment area. Our inlet structures are given a name, and the important thing here is it must start with a letter and end with a number. It can be anything. This could be gully pit 1, field inlet 1, or A1, B1, whatever you like. It must start with a letter and end with a number. So catchments are given numbers, junctions and nodes are given letters, and pits and inlets start with a letter and end with a number. That helps to tell the program what is what. I've just put on some links there. So now let's see what happens. We've got a node. The program will assume a constant grade between node 1 and node 2. Now if there is a change in surface level between these two nodes, we must tell the program that this has happened. So to do that, we enter another node, even though there's no junction coming into that. If we didn't do that, the pipeline would have come out of the ground there. So this tells the program that, hey, the surface has dropped. We've got a certain cover we need to satisfy, so it'll drop the pipeline to suit. We have the other instance where the surface level can drop. Again, you must tell the program this has happened, and we must enter another node where the surface grade has changed. That allows the program to change the pipeline to suit. Otherwise, the pipeline would go from surface level to surface level, including the cover. All right, so let's go back to entering our pipelines. We start with entering our catchment areas. I've already done it here to save us the aggro of doing it all over again, but let's look what happens when we do enter something. As soon as I press that, everything else disappears on that line. That is so the program can't make a mistake, and you can't make a mistake by assuming the data is correct. So if we go down and see what happens, it's also erased everything down here. If that didn't happen, there is the possibility that you could accept the original data, which is incorrect. So now all we do is we enter our area and enter our catchment type. If we don't enter the catchment type and press this, the program will pick that up as a fault and say, hey, you've got to select the catchment type. All right, so let's say it's a box cutter. We do that for all of those. Coming down here, we can enter those nodes in any order that we like. We can also leave blank lines. One thing you'll notice that the nodes always come in as capital letters, regardless of the setting of the caps lock key. This is so the program doesn't get confused with upper and lower case. So for instance, let's have another look at our roof diagram. So you can see what's happened here. I've gone pipeline 1 to A to B, B to C, etc. And if you look at that little diagram, you can see how it's done. And I've followed that all the way down to point E. It's shown in green because that designates it as the outlet. So you could have chosen to do it the other way. You could have chosen to go downpipe 1, point 1 to A, and then you could have gone catchment 5 to A, and so on. Got all the way down to C, then started again up at downpipe 2 and gone all the way down to pipeline C. In other words, you could have entered the data as the flow comes into the system. Well, however, it doesn't matter. You can enter them out of order, any old order, doesn't matter, as long as you don't duplicate it, as long as you don't have pipes going around in circles, all this sort of thing. If you do that, the program will highlight it as an error and tell you where it thinks where you made a mistake. In other words, if you've entered catchment number twice or the downstream point as a number instead of a letter, it'll pick all those problems up. So let's have another look at what's happened with the pipelines. You'll notice now there's also the opportunity to add rows and delete rows. So I can add another row down here. It's gone to 41, 42, 43, whatever you like. There's 40 default rows and you can add as many extra rows as you like and delete them again as you like. All rows have now been removed. Okay, so if we just press calculate pipe size here, we get a note that comes up and says function is only suitable for relatively flat sites. Because every grade is now the minimum grade, whether we like it or not. The minimum grade has been chosen, which gives us the pipe size we need. However, not all sites are flat, so we can calculate the invert levels. Because I've already entered the data, we've avoided a couple of potential problems. So let's delete some of this data, A to B. If I delete B, or just press on it, it deletes the whole row. Now I put it back again, we've lost some of that data. So when I press this, the program now says, whoa, please enter data in the cells with a dotted green border. Okay, so the dotted green border has told me now I must enter the surface level and the length for that point because we deleted it. So the surface level was 11 and the length I think was 15. Calculate again, so now look what comes up. It says our pipe's not going to fit. It says the top of our outlet pipe, ID 5, this is the ID here, outlet pipe, it's ID 5. It's shown in green. Green designates it's the final outlet. You can only have one final outlet too, by the way. If you have more than one, the program will say, whoops, you've had more than one, guys. See if you can fix it. Anyway, where were we? The pipe will not fit. The alternatives are increase the number of pipes or try a rectangular section. Click anywhere in this area, anywhere in here. We'll get rid of that box. All right, so we've got 150 diameter pipe. It won't fit. You see we've got an outlet of 10 and an outlet invert level of 9.8. So there's only about roughly 200 millimeters space to fit a pipe in, and this is when it's lowered the pipe, it's given it a 50 mil cover to allow for the sockets on the pipes. And by the way, if you've got a pipe going into a curve that's only got 50 mil cover, it's less than the allowable. So you could choose to use a steel pipe if it's an industrial subdivision. If it's in a normal domestic situation, well, it's part of the course and we do it anyway. So, all right, so our pipe won't fit. It said try 2. So let's try 2 pipes here. Because if we put 2 pipes, the odds are it might give us 2 smaller pipes instead of 1 bigger pipe. Let's see what happens. Well, we don't get that little red note anymore, so it fits now. You can read through that later. So 2 pipes have made us lowered the pipe diameter from 150 to 100. And as you can see, this has changed colour. When there's a change colour, I mean, I've called it dark pink, I think, but you can see what it means up here. The pipe has been changed, the colour has been changed because either the user or the program has changed the value. So in this case, the program had changed the value. But anything that's marked pink, the user can change. Marked pink, I mean, the user can change. And when the user changes that, that's why the colour changes here to let you know that, hey, it's not the default anymore. You notice when we came back before, we hovered over this, it changed colour. And the pointer and the cursor changed to a pointer. What happens if we click on that? It means that there's a link under there and a note. And it tells you why it's changed colour. So there's another thing too here. If you accidentally click on this one, warning, this will delete all entered data. But you did that and whoops, OMG, now what have I done? You can bring this data back by refreshing it, because what was in memory before is still there. It only changes when you press one of these calculate buttons here, it updates it. So what we had in the memory before is still there, and we can bring that back. If you press the little refresh button on your web browser, well, I'll do it now, you can't see it on the screen, it brings all our data back, so all is not lost. Looks, I've accidentally deleted that, I can't remember what it was, so I'll go back to my little refresh thing, and refresh things brought it back. We've got some extra columns here. We've got grates and grate sides. And by the way, if you hover over anything, any of these red things, and you see it's changed colour, there's a note under there with a bit more explanation. Click anywhere in this box to dismiss the note. So we'll notice that we've got the ponding depth is in here. That's the default ponding depth. We can make that whatever we like. And as you can see, it's given the default ponding depth. Now, the only things that have ponding, by the way, are inlet structures. And the inlet structures are shown with the red border. And there's no pipe. You know, it just flows over ground into the inlet structure, so there's no pipe there. However, there's a grate. So the grate size is dependent on the ponding depth. This is the head of water needed to push the water into the grate, over the edge of the grate or through the grate as an orifice. When it's got the A there, that means the area of the pipe, the size of the grate has been worked out by the area of the grate. So if you want to change that grate from, shall we say, a rectangle to a round, you must use a round that has the same area as the grate. So the area of the grate is 128 multiplied by 128 because it's a square grate. So let's see what happens if we put a very small ponding depth in there. Small ponding depth, I'll go down and press calculate. Wow, this has gone to a red. What's that? So hover your depth, hover your mouse over that and it says, whoa, this has been grossly oversized to fit the grate. Try increasing the ponding depth. See, the grate now has gone from a 100, almost 100 diameter side to almost a 1500 side grate. You know, it's 1300 square, but a P has appeared. That means the grate has been worked on the perimeter. So if you multiply that by 4, you'll get what the perimeter of this grate was. And if you want to change that to a circular or any other shape, it's the perimeter you must match. The diameter of the pit has changed to 1500 diameter just to fit the size of the grate. If the ponding depth was a little bit deeper, the grate would be a little bit smaller. The nearest grate to this may be a 500 square. So the pit has gone to a 600, but it's still got a different colour, which means it's not the default. So we click on that and it says, well, the pit has been increased just to fit the grate. Try increasing the ponding depth. If I put nothing in there, it would go back to the default, and the pit would go back to default. Pit's only 350 square. Let's have a look at here. Download the CSV file. Now this is interesting. You press that, or we can download the example spreadsheet, or, well, we really need to download both of these. So let's see what happens when we download the spreadsheet. You may see this up the top here, protected view. We need to click this so that we can cut and paste our CSV file into this standard template. The CSV file, when it is downloaded, looks like this. So we must copy our CSV data into our template data. So highlight the CSV data, all of it. We right click, copy that. We go across to our template file. The template file will be somewhere else. I've just added as another sheet, so we got them both in the one workbook. I come across to our template file. I must copy and paste it in this exact spot where I cut it from, which is this one here. So when I paste it, I must use the 1, 2, 3. Otherwise, you lose all these borders and other things around the place that you'll have to go and redo. All right, so that's that. So when we've done that, we'll move further across here and have a look at these two. Now, these are the things that actually do the calculation. However, the only thing we need to change here is this little number here. Put the start number for whichever pipeline you want to graph. If we go down here, we can see what the graph is. This is what it's done. And if we change the start number, it's number 1 there now. We change that to number 2. Remember, we had our top points for downpipe 1 and downpipe 2. They were the start points. So if I put that in there and I'll press the enter button on my keyboard, as you can see just in the corner here, it did change the graph. But it's followed pipeline 2 all the way to the end, the pipeline E. Pipeline 2 only goes from downpipe 2 all the way to point C. Pipeline 1, if you want to make this the main pipeline, goes from point 1 to E. So you can cut pipeline 2 off at pipe C if you want to, by simply stopping the calculation at that point. So if I click on this, line here, it'll show you what data it has used. It's used the data all the way down to pipeline E, but you can move that back up to pipeline C to D if you want to, on both of them. And if you press enter again, see it's moved that surface level down to point C, but it's carried on with the invert level all the way down, because I haven't changed it on the invert. If I press the invert line, the data it is using goes all the way down to the bottom. But as far as it goes, I could make that go further if I wanted to. Go back here, I'll put this back to where it was. Went down at point E, it doesn't matter where it goes to. If you have more pipelines than show on this calculation sheet, you can simply copy and paste these formulas further down. But the thing is, you must copy them in brackets of 2, as you can see here. They're all organised in sets of 2. Copy and paste them further down as many times as you like. Well, now, if you scroll further down, you'll see I have put a typical result. So this is the result that it'll plot out. Now, to turn that into that, all you need to do is copy the node data, or draw it in yourself, wherever you like, down these points. You might have to shift some of these out the road. Just click on it and shift it. And you may choose to add some more details like the grade and the diameter on each of those. Make sure you change the line number. This one, because we put 2 here, 2 smaller pipes, we need to make that a surcharge pit. Okay, so that's it. Go ahead, enjoy.